Quantum mechanics describe the strange properties and behaviors of single or small collections of elementary particles. In one such behavior, the particle can move through a barrier even if it does not have enough energy to do so. This is called quantum tunneling, and it had been confirmed only at a very small scale. Stephen Irvin, a theoretical physicist at Yale University, likened the phenomenon of quantum tunneling to the attempt of driving a car in neutral over a hill. If the hill is too high, the car won't have enough energy to make it to the top. Instead, it comes to a stop and falls back down. The hill, he said, is like an energy barrier that the car cannot get over. But if you were in a very tiny car and subject to the laws of quantum mechanics, even though you didn't have enough energy to go over the hill, he said, you could still get to the other side by a process called tunneling. Another property of subatomic particles is that they can gain or lose energy only in fixed, discrete amounts. This is known as the quantization of energy. Editors Hicks, why brittle bones aren't just a woman's problem. Why is everyone talking about Brown? 36 hours in prison, South Korea, skip advertisement, skip advertisement. With a large number of particles, however, these tiny quantum effects generally become insignificant. It is why humans, made of gazillions of atoms, cannot tunnel through walls. We always thought of quantum mechanics as a picture, which applies at the level of single electrons and atoms, said Anthony Leggett, a physicist at the University of Illinois-Urbana-Champaign. In the 1970s, he and a graduate student predicted that quantum tunneling could be observed in a larger system. The laureates of this year's physics prize confirmed that prediction. They showed, for the first time, that quantum tunneling is observable in a system they called macroscopic because it was big enough to get one's grubby fingers on, according to their paper describing the discovery. They also showed that the energy of this system was quantized, or existed at fixed levels. I'm very pleased, said Dr. Leggett, who won a part of the Nobel Prize in Physics in 2003. I had hoped they might get Nobel or something substantial for that work. The laureates made their discoveries by studying a ship with a circuit that was superconducting, meaning it was capable of conducting current with